Okay, so let's say welcome to our session. As the time is passing and we need time for discussion and the presentation, and we have to move on. So I'm Lazaros Georgiadis. I am the chairman of this session, but also the presenter of the first presentation. So I would like to ask somebody to remind me that I have 20 minutes. Please, ladies, just somebody to control me. The time stop. I was very fast. Huh? So I will start with my presentation. You can change the slides, or I can do it. Or I can, no, yes. Okay. So I will start my presentation with a multi-criteria analysis on decisions about the planning and a combination of roads and energy infrastructure. This work is part of my master degree, the University of Aegean, the program of Global Environmental Change Management and Technology, and the special program of Environmental Policy and Biodiversity Conservation. So we have to see the requirements of energy and transport. So you have to see that the demands of transport and energy infrastructure are constantly increases under the pressure of continuous economic growth and the need of adapt climate change. However, this is not without impact. This causes a series of drastic changes in landscape structure and land use by humans, and the degradation of ecosystems and changes in their structure with negative impact and all at irreversible level. We will talk a lot about reversibility in this presentation. The need for independence from fossil fuels has led the surge in the development of the renewable energy sources, RES, from now, which require the loss of land from natural areas. Especially in Greece, this is very important because this loss is not only just areas, but they are Natura 2000 sites, because we can allow the construction of renewable energies in Natura 2000 sites. So, in general, we can see there is a big conflict between development, adaptation to climate change, and conservation biodiversity. And related to the famous sustainable goals, you can see that there is a big conflict between land in order to achieve these goals. We are trying to find land for renewable energy, but also we need land for biodiversity. And all these land use changes are drastical input on the future of biodiversity conservation. We talk about fragmentation. This map is really famous, created by the EEA, talking about the fragmentation of the European continent in 5 levels. But also we have to have in mind that there is an Article 10 of Habitat Directive talking about the coherence of protected areas. Also in international level, the new global biodiversity framework is talking about integrity, ecological connectivity, and resilience of all ecosystems. This is the aim to have to achieve until 2050. And we have to see that the development of wind energy obviously requires the development of the road network in natural areas. Nobody's talking about that. When we talk about roads, we are mainly focused on highways or paved roads. And of course, the big discussion is how we can define roadless areas in this map, in one class map of Europe. So there are a lot of challenges. And then when we talk about sustainability, we have to say that until now we have 3 pillars of sustainability: environmental, economic, and social. Recently, there is a big discussion about one more pillar, which is reversibility of impact. Everything we are doing is reversible or not. Can we use this criteria as a sustainability origin for our tasks and plans? So, can we see how these global concepts can be adapted in local level? I'm coming from the region of Western Macedonia in Greece, and as all the regions have basic requirements for energy and transport, for the conservation, historical, cultural conservation, heritage places, and so on, local needs. but how this can be translated in local action. So the aim of this study is to create a decision-making tool using multi-criteria analysis, models, and geographic information systems that includes a framework of criteria for decision-making in the planning and siting of energy and transport infrastructure in Western Macedonia, based on the principles of sustainability in these 4 pillars and not 3. Creating alternative scenarios with the application of the multi-criteria analysis and corresponding expression in geographical mapping of the scenarios. And it's not in the whole region, but only the region unit of Florida. So the first results when we start to look about criteria is that we found some criteria based on these 4 pillars of sustainability. It's not necessary to refer to one by one, but just to say that there is a system that we can weigh to see what kind of criteria can be used and how different value we can give to each criteria. The other group of criteria we discovered is about criteria based on ecosystem services, on environmental planning in Natura 2000 sites. And another category of criteria is about renewable energy planning. And then we discovered that there are 2 categories, exclusion criteria and evaluation criteria. This criteria means that it's 0 or not. If we include it, we have not created or built infrastructure there. If they have to be evaluated, we have to see how much can influence the final decision. And at the national level, we find some very interesting criteria talking about how we are use Natura 2000 sites, but also the less fragmented areas, which are related actually with the roadless areas. And the final conclusion, the final, let's say, merging of all these criteria is this table that can use the criteria in these categories of the 3rd table, exclusion and evaluation criteria, but also we split them in other subgroups, criteria that can be translated in geographical information, and criteria that cannot. It's more quality criteria, let's say, that cannot be translated in geographical information. This is the region of Western Macedonia, and talking about connectivity, there are some very rough design about corridors, land corridors or aerial corridors. About this is one the Central Balkan direction of the migratory species in Europe. And this is an example of aerial corridor, because until now we talk about many of them terrestrial corridors. And we can see in this place, which is the Prespa National Park, we have the biggest colony of Pelecanus crispus, the Dalmatian pelicans. And these are the corridors that the birds use on the air, going from one lake to other network of lakes in Western Macedonia, because this is Western, this is Central, and a little more in the Eastern Macedonia. So we can see what kind of corridors the pelicans need, and on the other hand, we can see the Natura 2000 sites, and all these line areas are a proposal for corridors on the terrestrial level, serving the large carnivores mainly and the large mammals like rodents and wild boar. And we have to see that we need to see all these parameters together, and for that we need to see how to implement a multi-criteria analysis, which is really a modern tool that can see can use several criteria, not only one, that it can be related with a special subject area, and we have to see the scope of the decisions. We need to have stakeholders participation. It's not our decision, but it's just including all the society and the stakeholders. And we have, of course, to see how this dialogue can be effective. So in general, in the study, we try to summarize the criteria that we have find, and all this can be translated, let's say, in 5 groups of criteria. The areas, the protected areas, ecological corridors, the settlements, which means the society needs, the touristic areas, the energy and reversibility. And this can be seen in these columns, which are in a vertical position. But on the other hand, we make a method, a question in relation of which are the best direction that we have to select for the development. It's only investment, it's only environment, it's only society needs, it's only about tourism, or it's about policy. And we have to see if the policy is evaluating all these strategic direction or one of them. And in order to evaluate them, we made a system of value or weighting the selection of the stakeholders that we finally use to define the final, let's say, selection. So in this hypothesis, we have to see, we will ask the stakeholders that we used, see if the government have to choose one of these 5 directions I said, or to make a combination of the strategic orientations. So the categories or the group of these 70 stakeholders that we contact was related with the decision making, with environmental policy and development of transport and energy infrastructure, of advice and environmental licensing, on management of natural environment, and NGOs and universities. And it's not easy, but I will try to summarize the result of this communication with the stakeholders. We try to make two approaches. The first is to see what's the opinion of the stakeholders of existing status. So in these lines, we can see what they say that is the reality today. And in the second level is what is their proposal. So having this table, it's a matrix of the criteria that we used and the strategic orientation. We try to see the difference between the evaluation of the stakeholders of the existing and their proposed situation. And we can see 3 groups of answers. One is about answers that are very similar, what is the reality and what they are proposed. The second is a little bit medium homogeneity on the values. And the third is about the small. What this means, if you see the details, green, it means that in energy, they are all of the stakeholders agree that we need energy. And they all agree that, okay, we have to, we can live without it. It's a priority. No, it's the reality and we agree. But when we talk about settlement, society and tourism, there are some differences, some kind of differences. But when we talk about protected areas, ecological corridors, and reversibility, the situation is red. There is no homogeneity on the corridors, which means that they disagree with the existing data and they propose something different, which means that we have to evaluate protected areas, ecological connectivity, and reversibility. So, develop the scenarios in effort to translate it in the geographic information. But one of the main reasons outcome is what the issues that we raised from this from the study. The first is how much energy we need. The second is how we manage the fossil fuel that we have. How many roads we need, how many roadless areas remain in Greece. Can we say that the environment and social impact can be reversed in practice? This was a long discussion for all. Biodiversity against climate change or biodiversity for climate change. And this is one more interesting. Is the loss of biodiversity reversible or renewable? Is the loss of integrity of natural ecosystem reversible? Oh, sorry. Is ecological connectivity considered in the design of road and renewable energy projects? Is there a spatial planning of RES as an assessment of the cumulative effect, the big discussion that we have these days. Do you know about that? Do you know about that? I need the EIA yesterday. Never is time to make EIAs. Just the conclusion that everything is okay. And in a country that we call Greece, we have a big industry sector. Can we combine renewable energy and the wind farms landscapes? So we don't have time. We have 16 objectives that can be realized as a result. But I would like to highlight the integrity because I will show some maps just after. And there's diversibility, which is our key words of the study and the main discussion. And when we make the spatial planning, unfortunately, actually in Greece, we build, and after we finalize the building, we make spatial planning. So this is one of the conclusions of the study, which is a common sense of all of them. And how much we use scientific knowledge in the decision making, of course, the result is zero. And of course, we are not making stakeholders involvement because we would like to do what we would like to do. And what is very interesting of the discussion of the stakeholders is that the final table of the criteria didn't have the landscape approach. So the results of the involvement of the stakeholders is that we reach this table of the criteria, including also elements of the landscape action. And this is a kind of implementation of a view on geographical point. You can see all these narrows are aerial, let's say, corridors, but all these spots, yellow spots with the red around, are wind farms. Can you see that all these aerial corridors are meeting here, in a lot of other places? They are meeting the wind farms. Nobody evaluated when you just construct renewable energies. Something similar about this is the same. If we use multi-criteria analysis and include the opinion of stakeholders, these are the scenarios. I think this is without protected areas, you can not see it, but all these are Natura 2000 areas. So stakeholders believe that we have to make a little bit more, 2 kilometers outside of the Natura 2000 site. But if you see here, this is very characteristic. These are already constructed wind farms. These all red spots. And these big yellow spots are new photovoltaic parks that come. And again, this is Natura 2000. So it's the same about terrestrial corridors, and it's not so simple to understand the reality. It's actually no planning, nothing about conservation, nothing about reversibility, just build things. And we have a lot of proposals. We don't have time to see all of them, and we can say that just because we don't have time, all these concerns that are in global level, at least in local level, just this is the conclusion. Then this is the reality in Greece when we talk about spatial plan. And I like to finalize it because we don't have time with this. Thank you very much for your attention. I know that it's very difficult thesis of 1 year to be presented in 20 minutes. And as we discussed with Marlene, it was a presentation of half an hour, and then I cut it to 20 minutes. And it was very difficult to squeeze it in. So I hope that you don't have questions and we can discuss it more. Otherwise, we have to move on. Thank you for the press. And we have the issue because the second presentation is missing. So where is Karim Farouk? He's not here. Which means we have time for questions. Lucky me, lucky you. If not, yeah, bless. Please, Eric. Yes, and this is, it was a question here or not of the topic that we discussed. Climate change, biodiversity against climate change, or biodiversity for climate change. Okay, and it was a lot of discussions about how we use the green infrastructure. And it's a nice question, this, because for all of them, especially the politicians, they say, okay, I have a quarter, but I don't want to do it during the morning because I have a lot of meetings. Let's do it in the afternoon. Can you come for a coffee? Say yes. And we spent 3 hours instead of 20 minutes. It was endless for all these 70. I mean, everybody, I would like to express that. All people was interesting to see what all this concept believe. And everybody was really concerned and really aware of the situation, of where we are. But anyway, this is governments. Please.
And biodiversity loss. There's a lot of work on that, but why do you think the role of road infrastructure is often, it's not explicitly considered when we try to predict biodiversity loss or land cover change? Why is it that we often ignore the role of road infrastructure?
I would say something different. I used to work with NGOs for 20 years. We spent months to have an appointment with the ministry. And when we achieved, the same day, an investor came. The discussion between us, minister, and the investor and the minister were different. It was the investor was talking to his secretariat. So lobbying is lobbying. We are begging for an appointment for months, and they have a call, and the investment is done. What else? In the European level, Brussels is the capital for lobbying. It's another question. We discussed it. We didn't want to open the discussion. How legal, how ethical is officially to recognize the lobby, which means come to my office, influence as you like, and okay, I will make the decision after a month. But I'm not alone in this session. I think I propose we have to decide that we have to move on. We have more time for other questions for the next presentation. So if Khalid is not here, I would like to invite Steve.
Good afternoon, everyone. If you don't mind, I'm going to take a seat because I can't juggle this, and my notes at the same time. So hopefully the slides will be exciting enough that you won't have to worry about looking at my face anyway. But yeah, to kick things off, my name's Steve Bega, and I'm the technical director of a company called Animex International. And today I'm here to talk to you about a project we've worked on with Devon Wildlife Trust and National Highways in the UK. Now, this project itself was part of a scheme called the Network for Nature. And this was a partnership between National Highways, the Wildlife Trusts, and the aim of this overall project as Network for Nature was to mitigate environmental impacts and damage caused by historic road building activity within the country. Now, there were many smaller projects as part of this project that contributed to the overall scheme that were deployed and developed across the country. And we were lucky enough to work on 2 of those. but I'm just going to share one of them with you today, which included how we explored using existing infrastructure on the network to improve wildlife connectivity. I just want to say thank you to Devon Wildlife Trust and National Highways for the help with this project, and in their absence, I will do what I can and my very best to tell the story of this. So, I'm getting caught up in the DJing aspect already. So, introduction-wise, the slides I'm going to share with you today, these are all pages taken directly from the draft Phase 5 final report of the project, and we called the project Creating Species Highways. Now, this report was intended to be a bite-sized, easy-to-digest summary of what the entire project involved, so that it could help stakeholders to understand the concept of using existing infrastructure and how that could be used to potentially improve wildlife connectivity. Now, we also wanted to provide them with reasons why this is a good idea, and also demonstrate how this could be achieved on some actual sites at a local level. So for each stage of the project, we produced many in-depth reports that contain a lot more detail and information than I'm able to share with you today. And this report is not actually currently in the public domain, but if anyone is interested or would like to know more about the project after this, then I will share my email on the final slide. So as I mentioned, this project was all about exploring how we could utilize existing infrastructure to improve habitat connectivity for various species within a county of the UK known as Devon, and it's just kind of slightly towards the west coast. Now, we wanted to see where there were opportunities to enhance existing underpasses and overbridges to provide better or new connectivity for a list of target native species over 2 main roads. Now, new wildlife crossings, as we all know, and green bridges are amazing, but we also all know how expensive they are. So in Europe, we all have a lot of existing infrastructure that dissects valuable habitats. So we wanted to explore locations and mitigation options for these retrofit enhancements that would provide the connectivity, hopefully at a fraction of the cost of new structures. And those 2 roads that we focused on, one of them pictured here on the left, is the Devon Expressway, is the A38 and the A30. So the methodology for the project was split into 5 phases. Now, phase 1 was a review of the ecology and behavior of all the target species. There were 17 target species that were chosen by the Devon Wildlife Trust, and this was based on their conservation value and potential to be impacted by the road network and the fragmentation. Now, a desktop study and literature review was carried out for each of these species, looking at their key habitat requirements, their reproduction, foraging behaviors, impact from roads, road mitigation measures, and crossing feature requirements. There's quite a lot of things we looked at there. During phase 2, we researched existing crossing structures. Now, this involved, again, another desktop study and literature review of the most common road mitigation solutions across the world, as well as targeted specific road crossings that were more relevant to this project. In phase 3, we conducted a review of structures to identify potential crossing locations within the county. And to do this, we used a points-based system to narrow down the original list of structures that were provided by National Highways. And the following six stages, were used, and any unsuitable structures were eliminated from the list at each stage. So at stage 1, all structures were overlaid into QGIS, and any structures not within Devon County were removed. In stage 2, habitat suitability modelling was input into QGIS and used to identify structures within the likely or possible range for each target species. During stage 3, I used satellite imagery and Google Street View to assess each structure for connectivity, looking at potential habitat improvements, adjacent lands, constraints, and any other relevant information. During stage 4, suitability for specific species, including great crested newts, common toads, narrow-headed ants, and reptiles, was examined. These were examined individually. We're searching for features such as ponds, nearby populations, along with any habitat connectivity. Stage 5, National Highways and the DFBO structure reports were used to identify potential opportunities for structural or connectivity enhancements. And then finally, during stage 6, each structure was assessed and again classified as high, moderate, or low priority. During phase 4, this involved the examination of potential crossing locations, where a desktop study and site visits of the 13 structures shortlisted during phase 3 were conducted. The desktop study included a search for water bodies surrounding the structures. There's exploration, presence, absence data for target species, and identifying the location within the ecological network. The site visits were carried out on a 100-metre boundary. This was centred on the structure and included what's known as the UK Habitat Survey, biodiversity condition assessment, and just a general site assessment to identify any enhancement opportunities available. And then finally, phase 5, that is what I'm kind of currently showing you now and will continue on the following slides. So summarising this project, as I mentioned, this report was intended to be a kind of bite-sized, easy to digest summary of the entire project that could help stakeholders to understand the concept of using existing structure to improve connectivity, and also provide them with some examples of why it's a good idea and how this could be achieved. So we therefore wanted to keep everything as simple as we could. So as part of that, we identified 3 categories of enhancements. We believed these are essential when considering any adaptations to a structure to improve the connectivity. These enhancements are split into, firstly, connectivity features that facilitate the passage of wildlife through a structure, barriers that strategically guide animals away from roads and towards crossings, and then finally, habitat enhancements, which are designed to attract wildlife towards crossing structures, looking at the habitat around each structure. Now, individually, each of these enhancements offers benefit for wildlife. However, obviously, when using all 3 together, each component provides and improves the effectiveness of the others. So looking at these in more detail, we've got connectivity features and how we define these. So again, we define connectivity features as the physical interventions you could add or apply to a crossing or a structure to improve or facilitate the movement of wildlife. These features can be natural or artificial. Many of you would have seen some of these before, and encourage the movement of terrestrial, aquatic, arboreal, and aerial species. Now, we identified the following 8 features as being the most appropriate specifically for this project. And this includes, as you can see here, arboreal bridges, living walls, mammal shelves or ledges and otter ramps, as well as furniture, raft gardens, and then also temporary and permanent forms of reclamation and transformation. We then identified and defined barriers to be features that can and have an impact either controlling wildlife movement or keeping them basically off of roads or guiding them towards crossing structures. And we split these into 2 different types. One being natural screening, which we stated could be achieved by planting a line of closely spaced trees on both sides of the carriageway. This would then help to increase the flight height of certain birds above the road, and then also help guys back to crossing structures. The other, as you've seen before, as artificial barriers that include your kind of traditional wildlife fencing, sand baffles, and road screening. And this would help to prevent terrestrial animals from entering the roadway and then hopefully also guide them towards any crossing structures. And then the third category being habitat enhancements. And as I said, this focuses on the improvement of the habitat surrounding each structure to encourage animals to utilize the crossing, but then also help them to disperse more widely into the landscape. Now, these recommendations were all made in line with the UK's biodiversity net gain habitat improvement policy, which is relatively new. And this included woodland improvement, grassland management, marginal bank planting, And we also made recommendations for artificial enhancements, such as nest boxes and hibernacula for reptiles and amphibians. So moving on to the structures themselves, as part of the study, we looked at over 950 different structures, and these were shortlisted down to 13 during phase 3. And within the phase 5 report, we narrowed these down to just 5 to provide examples. We separated and defined the structures as the following types. Wet. Some of these may seem pretty obvious, but we defined them nonetheless. So a wet underbridge is defined as having 100% of the area within the structure covered by water. Dry. No prizes for guessing what, but this is an underbridge that's defined by having 100% dry land within the structure, no water. Wet and dry. An underbridge that has a mixture of water and land passing through it. And then we also had an overbridge, which is a dry open structure passing over the roadway. So under each of these categories, we then explored and presented the top 5 connectivity features that we identified to best suit these types of structures and target species, and we laid them out in each of the sections on the pages here. For example, for this wet structure, we shortlisted arboreal bridges. We've got living walls, mammal shelves and ledges, otter ramps and raft gardens. And then we proceeded to specify and demonstrate which enhancement from each of the lists we would recommend for each site. and the structure. And then within this category, we demonstrated how this could look with an image from a simple 3D model of each structure. And then these are just a screenshot from the models that we made, but we've got these models and we share that you can kind of look at the structure in its entirety in 3D. And again, the aim of this was just to present Highways team and any other stakeholders with an exact example of that structure. Looks like that. This is the type of enhancement you could put on it, and this is how it looks. So they didn't have to kind of imagine anything. They could just see for themselves, oh, mammal shelf, what's a mammal shelf? Oh, it kind of looks like this. This is how it could look on, you know, this project in particular, or this structure in particular, as a kind of river lemon culvert. And then we were kind of hoping that by providing a variety of different options on different types of structures and creating these visualizations, it would just make it easier for them to understand. So here, these two structures were known as the river lemon culvert, and this one was Dog's Bridge. Then moving on to the dry structures. So for the single dry structure that we shortlisted, we demonstrated how a living wall could be applied to the outside and the inside of this underpass. And again, you can kind of see that here on this location known as Breezel Overspill. There is a small tributary of water down here, but it wasn't considered to be of any kind of real use or value. And then we have wet and dry. So for the wet and dry structures that were shortlisted, we showcased how reclamation and furniture could be applied. And again, looking at two sites specifically, we have this larger structure, the River Tean, and then Breezel Water River, slightly smaller structure. And then finally, for the two overbridges that were shortlisted, we showcased how a form of reclamation, known as the Habitat Highway, and an arboreal bridge could be retrofitted. You can see this side, it's just talking about reclaiming some of the concrete on the side of the bridge, and this is kind of an arboreal bridge retrofitted, kind of like a rope bridge you may have seen elsewhere on top of the concrete structure. And then after we identified and presented the 5 best structures and provided examples of how various interventions could improve the connectivity for different species, we wanted to show different reasons why you may want to or need to improve the habitat connectivity. So initially we showed how the initial 13 shortlisted structures could be used to provide landscape connectivity, and we split these into 5 key zones. And then we plotted each structure on the map as you can see here. We then went on to explain 3 key reasons why improving habitat connectivity could and should be considered. And we split these up into 3 simple reasons, one being maximizing range, and the others being maximizing habitat and also connecting isolated populations. But what's next? So just to recap, our aim again for this project was to introduce this concept of using existing infrastructure to improve the connectivity to national highways and other stakeholders within the UK. We wanted to demonstrate how this could look in a real world context by assessing the 2 main roads in Devon and also identifying which structures could be best suited for the enhancement. We then explored and presented enhancement ideas and examples that could be considered for implementation. Right now, this report is in the hands of National Highways, and to our knowledge, it's contributing to a business case being made by the agency to present to national government to hopefully draw down some funding and also influence policy there so that connectivity is a thing that they have to do, and there's reasons why they should do it, and people will be rewarded for doing it or held to account if they don't do it. So as far as we're aware, there are no other explorations or considerations for this project and taking these ideas forward, but we are, to be continued. We are, however, working on a project in Southampton that follows on these same lines, which we're calling Rebuilding Bridges, where we're looking at trying to partially green an existing concrete bridge to see how that can help to improve the connectivity for wildlife on a particular structure. Right now, we are going through a kind of review stage with Highways to determine if what we want to put on the bridge is going to be safe and structurally sound for the structure. So the engineers are currently reviewing the kind of size, shape and loading of that, but I've run out of time. So if anybody has any questions or would like more information on the project, please feel free to ask questions or get in touch. Thank you. No, it's a pleasure. Does anyone have any questions? No, so it's not publicly available yet. So we submitted this to Highways, and they've been, we hope, looking at it internally. So if I could share some information with it on you. Yeah, I can share some information with you. I can't share the physical reports, but I can share some information on it. Yeah, I think I just realised that's not my personal email. You can put Steve in front of this, and it will work. If you do email that, it will come back to me at some point via a colleague of mine. Any other questions? Thank you, everyone. Appreciate it. Sorry. Okay. Hello. So I'm Koen. I'm working with Sweco, and I'm now representing ROTS for Lantis. Lantis is the government organization who builds Oosterweel. It's a highway project with tunnels and bridges at Antwerp in Belgium. Small disclaimer, I made this presentation, same as my name, very big one, shortened, so I will skip some pictures or some text. I hope you get it afterwards. If you want to read it, you can read it afterwards. I came also to Eindhoven, 2018, to IENE. I had also there a presentation about Oosterweel. We had construction phase, now still going on some places, but some other places already finished. And I had some lessons learned there about all the studies we see here, how to build ecoducts or how to monitor them. I sit in between. I try to build them. I try to maintain the proposal in the beginning to be built as planned. So the first time I think in Belgium we designed infrastructure regarding ecology. So we tried to see where the bridge must be built during construction phase. I think most other aqueducts are built afterwards. So it's retrofitting. This is the one where you have eco-tunnels and eco-ducts built together with the highway. This is the area. The city of Antwerp is on the right side. This is the first phase. We are building a ring road around Antwerp. So this is the west side where the ring is first made. And afterwards now starting the east side of the city is now taken into account. So here is a tunnel. You see here the entrance. It's coming out somewhere to the other side. So that this tunnel is now being built also. The project's already going on about 10 years. So I'm from the beginning in the project. We have the design, we have construction, we have also now helping the contractor how to build it, how to maintain green. You see lots of green areas also where the highway is crossing. So it's a balance between densely populated area, here city, there the big city, there the port, also economical value. So how to maintain this. That's still from IENE 2018. So we have infrastructure, how we want to look, how we want to connect the roads, and then this is together merged with ecology. Like for example, we have some pools for toads or some green infrastructure we want to combine. This is one nice picture of the project where you see we have the highway. Here it's the first part of the project. The tunnel is not yet
the design. So the tunnel will come here. And we have here also bicycle paths, the red ones. We have eco-duct, but we have eco-duct crossing with bicycle paths separate level, so the bikes don't cross the animals. Now the project has gained some more finances, so we have adapted the project along the way, and the bicycle path is a separate bridge now. We have two bridges, one eco-duct, one bridge for the bikes. So we have gained some money. Also, we have to lose some money. We have to compensate some other things. We have to change along the way. So construction phase. We had a long planning phase. I think the project is already mentioned late 80s, beginning of 90s. So then was a bridge, and it was a tunnel. It was a long phase of debating how to do it. Still, some things were unforeseen. It's mostly ecology, because ecology was not foreseen in the beginning. We have tried to make an EIA, look at every point of it. But for example, beavers, now it's a new species in Belgium, didn't exist in the 80s or 90s. They try to enter the construction zone while constructing, so it's a bit difficult. They are now flooding the construction zone. So how to deal with this? We have environmental issues also. We have a big pollution area. We'll come to that later also. How to deal with differences in the soil. For example, you measure at the beginning, water level will be this high, and afterwards the water is this high. So your tunnel restraining, remaining height in the tunnel is less. So it's not suitable for bats anymore because they want more space for bats. Only fish will cross then the tunnel. So how do you adapt all these things? We have Natura 2000 habitat. We have Natura 2000 species. We had some translocations from toads, netterjack toads, for example. It's a long process, and I think some pictures will make it more clear. This is the original phase 15 years ago, I think, and this is the design. So you see, today or previous, it was lots of green. Already this green, here you see it's cutting. It's an old green alley here, so it's already cutting here. Also, this alley is cutting this big forest in two, and now we are making the tunnel here, so it cuts additionally these two nature areas in two. So we have to compensate for this new barrier, and we tried to, you see the two bridges now, it's two bridges. We tried to compensate here also for the existing infrastructure, and this old road is demolished. It's now only bikes, so the animals can cross more easily. In construction phase, for example, we had to help the contractor. He was not used with birds or bats or toads, whatever. We have to help him on the terrain. We could say not chop down the forest in breeding season. He still wants to go on, so he just chops down the trees. We had sand martins. They see a big building site. They have sand, and they want to build nests. So if there's a nest of the sand martin, you cannot build. So it's a little bit difficult. We have to prevent them to make nests. We had orchids, so it's protected species. We had to translocate the orchids. Where do we do it? When do we do it? How do we do it? It's all knowledge we gained along the process. Nobody ever did translocation of orchids in Belgium before. We were the first one to do it. We were the first one to translocate the toads. It's all new. It's all process for the ecologists, but also for the contractors, how to regulate his work with nature or with breeding season, or how to do it. Main thing important to remember is close contact. So every 2 weeks in breeding season, we were on the terrain to help the people on the terrain. Also close contact with the government, local NGOs, local cities, local citizens also because they were affected by the noise or whatever of the construction. Expected and unexpected, that's also very important. For example, PFAS, it's also now known nowadays. The biggest plant in the world is in Antwerp. So the source of PFAS is Antwerp. So the soil, we wanted to reuse the soil, but it was polluted, so we have to dig it out and bring new soil. So that's also a problem there. The green or ecology was in the beginning. We had green in the beginning. We want to maintain it. We want good green or ecology space at the end, but also maintain it during the construction phase. We have 10 years to go. In these 10 years, you cannot say all the frogs, all the birds, we just destroy them and they have to come back later. No, we have to maintain them while building. Here, this is 3M, is the chemical plant where all the PFAS is going from in the world. So we are building here this highway just next to it. All this soil is all polluted, so we are all to take into account to see all. We have to dig out here this little stream. Problem, of course, there is when we want to dig, all the sand is polluted, so we have to deal with this. Yeah, we had difficult things also. Antwerp is one province. We have West Flanders. The tunnel elements are built in West Flanders, so we have to also cross boundaries of provinces. We have to cross these tunnel elements over sea. So also there's an impact on the sea. We have protected species, but also invasive species. What to do with it? How to maintain them? How to monitor them? This is the city of Antwerp. Will be changed also there. It's lots of text. You can, of course, read it afterwards. Monitor. I think everybody said it, monitor, but not only concrete strength of the bridge, but also how to grow the green on the bridge. We have also put nest boxes to compensate the loss of green for temporary housing of the bats and birds. Contractors doesn't know nature, so help them. Also there, try to speak their language and hope they come to you and ask how you think, how you see this. Yeah, I think it's quite the same as this morning. The first presenter also had the same recommendations. Educate the public, the common people who have to use the road, also the government, because we invented here things to reuse for next projects, not make the same mistake twice again. I think it's, yeah, also be open for bad results also. You have to make mistakes. That's the process of learning. So you make mistakes. Sand martins, we made a special nest box for sand martins. We have still sand martins here. The orchids, translocation of orchids, special way how to do it. Special plants, protected plants. Here also we had trees, little trees, not just shut them down. We reused them for a local school to make more green play gardens at the school. Yeah, we did some fishing, metaljack toads, on fish. Swallows, here also the metaljack toad, how to migrate, nests, construction phase on the, also monitoring of disturbance, other than if we have nest boxes we hang. So this is my final thing. If there are questions or other experiences of your projects. Thank you. Yes.
Thank you. I was wondering, you said that the contractor didn't have any ecological knowledge. Did you have any criteria for selecting a contractor that had the required knowledge?
Yeah, it's very difficult because also the project evaluated during the construction phase. Like I said, one bridge, now it's two bridges, bikes and green separately. Lantis, the government has chosen the contractor regarding his effort or his recommendations from construction sites. It's the first, like I said, it's the first time ever in Belgium where ecology and construction is seen as one. Previously, it's only just built on concrete, and afterwards, if we have a spare spot, we plant a tree in a spare spot. So this is the first time. I think nowadays they have managers who also look to the environment. They see how to compensate, for example, some forest or some animals. You cannot choose a contractor on his references of green. It's also not in Belgium. It's not existing. So we did his job. We did the green for him. We tried to, like the orchids, we translocated orchids before he began. We placed the nest boxes before he had to chop down. So we did it all in advance. We prepared, and then he could go with his concrete or with his business. But although the St. Martins, they came during construction. So we had to stand next to him on the field to help him. So it's a process.
Other question?
Continuing the previous question, do you find it necessary to train the people that are working on the site? It was something that we saw in our project in Greece.
Yeah. It's
Because
very.
if they learn how to do things that previously they were it was done in another way, maybe it will not, if everything will be better and not be be necessary to be supervised.
Yeah, that's true. But of course, ecology is very broad. You have the protected species like orchids and toads. You have also the invasive species like the knotweed. You have to have many people knowing all these parts. So there's one person from the contractor checking all the site for Japanese knotweed. But if he finds one, he pulls them out and destroys it. There are people looking for nests, not for the nest, of course, but for the St. Martins, looking for straight sandbanks, how possible they can nest there. So several people, of course, it's a very big site, construction site. So every person has his part of the job, and they only look at their part. So it's difficult. You still have to help them. You have to educate them. You have to be there if there are questions. They don't come to you with questions. You have to ask, do you have a question? Have you seen this, for example, this bird or this plant? Oh yes, many times, yeah, but it's new. We are lucky with one thing. We have many Dutch colleagues. In Holland, the regulations are more strict, and there they look, the contractors, for bats or birds or plants. So the Dutch colleagues come to ask for us, is there not a bat we have to look for? And the Belgian colleagues don't know it. So it's also cultural. They know him in Holland, but in Belgium. So it's growing knowledge. So it's also the reason why I come here, to make sure don't make the same mistake. We learned, we made the contractor learn. So he has also an advantage now for next projects. He can say, I did this project, it is the same question you asked. I have this knowledge now, I can do it better than before and than my colleagues because I have done this before. So win-win, I think, for everyone.
Okay, thank you, Gwen. And now I can invite Marlene to the floor.
I will talk about Vademecum of road infrastructure, part ecological engineering. I speak on behalf of the Agency of Roads and Traffic of Flanders, part of Belgium. The Vademecum is a publication of the Agency of Roads and Traffic, the Flemish part of Belgium, and it's for planners and project engineers to realize ecological engineering along roads. It's not a copy of other guidelines. The Vademecum is an engineering supplement. The purpose, the goal of the Vademecum is to integrate the natural values more in projects, not only to build natural connections, but also to take more opportunities, other opportunities for fauna and flora. For example, the design of the surroundings of the environment, and how to build verges, and how to take care of water management and ditches. It's based on several existing manuals, European manuals, and existing manuals in Flanders, and it's also part of a series of manuals that is used by the engineers in the agency, in order that they also use it as a manual within the agency. So the other manuals are about motorways, bicycle paths, and so on. And this is then the part about ecological engineering. Flanders is in the center of Europe. You know, Brussels as a capital, not only from Belgium, but also for Europe. And you can see it on the road map that there are many roads centered there. And on the right map, you can see that our country is very fragmented. So our natural areas are very small. So it's even more important to have connections between the areas that are still there. The road building in Flanders is fast. So we should not have more roads than we already have. But we're still building missing links and wingways. These are vast and long projects with a long planning process. But we have also many projects on existing roads. They are adapted to new standards. It's a restoration of the pavement, and that are projects that don't require always a building permit or assessments, and but they have they give many opportunities to integrate measures for defragmentation, for small measures, and between natural areas, not always in a natural area itself, but in between. This is also very important. And so project managers do not always need to get an official advice. So they do their project and so the guidelines are very important so that they can do it on their own, especially with small measures. A bottleneck is the difference between to get advice or to talk with each other. A civil engineer speaks another language than the nature and the water managers. You never make a biologist of a civil engineer. So you have to give strict advices. They have different goals for projects. The Vademecum is a tool for taking advantage of opportunities for nature measures, not during major works, but especially on the small renovation and maintenance works. Paying attention to the natural environment and using opportunities to improve an existing situation. So the goal is a solution-oriented manual that should make the application of ecological technology easy to apply. It's providing targeted information to planners and designers at all steps of the process. So the first part is about the planning process. And the second parts are different sheets that give more technical information. The target group are governments of local authorities, NGOs, and all kinds of designers. Also, training and research institutes are a good target. It should be, the Vademecum should be included as a mandatory guideline in specifications for designing assigned sites. The structure, as I said, was first a planning process that gives information about every step of the process, the obligations and necessary information, and with the goal that measures are taken into account from the first steps of a project, and not afterwards when the project is nearly ready. The sheets give the technical information, and because we want to emphasize the importance of the small measures, we give them first and then the rest. And we don't give information about the why, but only we focus on the how. This is a table where the engineer can see what kind of project he has and what kind of measures he can take or must take, of taken into account in this project. The structure of the different sheets is always the same, but the most important are the information about the right location, the conduction, technical design, and the setup. Some basics. It's important to have a well-designed verge so that an ecological mowing management is possible afterwards. Avoid extensive wide connected waterproof pavements. Create space for water, avoid lighting. Reconstruct, and I find the most important message. Take all the culverts that are in our project and see if you can adapt it so that animal can cross there. And another one, never place a fence or other barrier along the road, only to avoid fauna victims or for road safety without existing or planned crossing facilities. The message create guidelines in the language of an engineer. Don't only give official obligations, but sit together, and together you can find better solutions. Do not only focus on big projects and large measures, but also on local roads and small measures. Do not focus on only big natural areas, but only on intermediate areas. And also, I do not focus only on the fragmentation, but also on road equipment, so lighting is. So my suggestion is to give within IENE also more attention to the technical and focus so that road engineers also are more interested in how to do it separately from the scientific way that gives, yeah. So, but I learned that in the meanwhile, IENE is part of TRA, the platform for engineers. So that's already a good step. That was it. Thank you.
Thank you, Marlene, very much. Questions, please. Then we can go on. Tobias, please, it's your turn.
Thank you. So I'll see if I can juggle all of this, my notes thingy first. So my name is Tobias Salman, and I work as an environmental specialist at the Swedish Transport Administration. I'm going to tell you a little bit about the Swedish standard for mapping and assessment of habitats in nature service that we use for instance, for impact assessments and as a basis for planning of new infrastructure. The Swedish Transport Administration, I'm going to use STA for short, build and maintain road and railway in Sweden. It is the largest purchaser of construction work in Sweden, and we are also the largest purchaser of nature service used when planning construction projects. And we have purchased these service for a very long time from ecological consultancies. In the early 2000s, we saw some problems with our nature service. Surveys were carried out by different consultancies, each using its own internal methods to evaluate and categorize biotopes. The companies also had different formats for reporting and providing geographic data. The quality of service and reports varied, and county boards, that is the regional permitting authorities, routinely requested additional service in our projects. As a result, the specialists at the STA, at that time, had to spend much time describing how the service should be conducted. They had to spend time understanding differences in the company's methods and checking the quality of service and reports. And of course, explaining all of this to the county boards and other stakeholders. We got a timeline here. Around 2008, the SDA began discussing a solution to these problems with the consultancies and other stakeholders. The conclusion was to develop a national standard for biodiversity assessment and habitat mapping. A few years later, in 2011, a technical committee was established under the Swedish Standards Institute. Participation in this committee is open to anyone who's interested in taking part in the work, and it's voluntary. Over time, representatives from around 10 consultancies, a large municipality, Swedish Environmental Protection Agency, and the STA has participated in the committee's work. The STA has held a chairmanship and been a driving force in the committee from the start, with Anders Sjölund, Johan Rydlöf, that you perhaps have seen here as chairman. So, the standard. The purpose of the standard is to create a framework of principles, requirements, and terminology that can be used to assess areas according to their importance for biological diversity. This framework is agreed upon by the members of the technical committee, and as you remember, the committee is open to anyone who wants to have their say in this work. The standard includes requirements for how a survey should be planned, what background data should be collected at the desktop, how it should be conducted in the field, and what type of competence is needed to do all of this. That's quite important to understand. What do you need to know? What type of competence do you need to have to make a good survey? The standard does not specify an exact method for surveying and mapping different species or nature types. There are already loads of published methods, and the particular survey method should be chosen depending on what species you expect or what nature types you expect in the survey area. But one key part of the standard is to define terminology. And it includes definitions for around 120 terms and key concepts. So you know what you're talking about. The standard should be viewed as a kind of toolbox that describes a main survey type consisting of biotope mapping and assessment, and around 10 additional survey types. For instance, targeted search for certain species or mapping of certain habitats that can be done either independently or as an add-on to the main biotope mapping. So the main survey type is mapping and assessment of biotopes within a designated study area. Such a survey begins by collecting background material such as results from previous surveys and information on prior species observations, and, aerial photos, and so on. Fieldwork is then done in such a way that all parts of the survey area is visited. That's a requirement of the standard. The timing of the visits should be planned so that species and structures that are expected to be important for classifying biotopes could be observed. So you might need to visit the site several times during a year, not just once. During fieldwork, areas with similar habitat qualities are drawn on a map, and we call these areas biotope objects. I'm using the standard is in Swedish, and all the translations of the terms are my own so far, but we are working to translate it some parts of the standards into English. So look out for that. Very interesting. The importance of biotope. Let's try again. The importance of biotope objects for biodiversity is assessed based on two components: species value and habitat value. So, to put it simple, the more signal species, indicator species, or rare species found in a biotope object, the higher the species value. And the more features indicating long continuity or rarity of nature found in a biotope compared to the landscape surrounding it, the higher the habitat value or biotope value. These two parameters are weighed together to get a conservation classification between 1 and 4, where 1 indicates the highest importance for biodiversity, whereas class 4 object has some importance for biodiversity. After fieldwork, a report is compiled describing the area's main characteristics, the biotope objects that are found. Like you get this kind of sheet for every object. And obviously you see the objects on the map along with the different conservation classes. And so on the sheet, you get a motivation for why you have classified a certain object as a class 3 or class 4, and so on. Finally, and it's quite important, I guess, it's that all this information is still delivered as geographical data, and we have a data product specification. You see this complicated thing with arrows that defines the structure of this GIS deliverable. So, after this standard came into use, you see that we get comparable surveys that use the same terminology and the same basis for evaluating nature. We have a common language for communicating about surveys between authorities, clients, and the consultancies. We have a shared understanding of the method, and we also receive data structured in the same way from all consultancies. Hopefully, in the future, this data can be stored in a national database, along with the results from other actors. Acceptance of the standard has been high from the start. Almost everyone planning construction projects use this standard. And approximately 1,000 surveys are conducted in Sweden per year. Thank you.
Thank you, Tobias. Any question? And if we don't have any question from Tobias, again, if you have any question from the previous presentations, please feel free. Or if you want to say something from somebody from the presenters, something else, please feel free to express your thoughts. So, last chance. Eric, please.
Mapping natural books. Mapping natural habitat could be, of course, very interesting. And I don't know which country could have this opportunity, but I know Spain or Italy have this kind of map, natural habitat map, on their nationwide, their territories. In France, we should have it next year. And I want to say that it's very useful because you could have the French National Museum have the knowledge of which protected species are in each habitat, in each latitude, and to provide information about prioritization of each habitat you have in the place you want to carry out your study, and provide you information about where you should prioritize your sampling, and also regarding low consideration of corridor, of course. But it is very much to gain information about prioritization and protect this area, prevent it from road construction. And you could do it in the size of a region if you wish. So we haven't tested it. I hope we could test it in France a few years, but I think a museum have tested it in single small places, and it's not so bad results. So you could have many information with natural habitat because it concentrates many information about botanic, plant species and animal species. If your database is strong enough, of course, of collection of data.
You mean to use in our case in Greece?
Yeah.
The problem is not the availability of data. We know where Natura 2000 are. The point is that there is a decision to not include it, Natura 2000, in the exclusive criteria. Which means that there is official governmental decision to create anything you would like inside to Natura 2000 South, independently if we have species or not.
Natura
Who
2000.
cares actually for them?
Natura
Because
2000.
Natura 2000 sites are because we have species inside. We know there is the SDF. We know what the species.
You don't know outside.
Oh, of course, yes.
No, not at all. Depends on the countries, of their development of their data, their database in each places. But Natura 2000 is a part of the puzzle.
Mhm.
You could add other places, and what happens between all these areas. And so having a natural habitat in no place, even outside of natural habitat, Natura 2000.
Imagine if we ignore the presence of the species inside of Natura 2000 site. Imagine how much importance we give in the cases which are outside of Natura 2000 sites.
No, it's most important because you could.
Yes,
you could
I agree, but what is the status? What is the reality? How a EIA can be approved when the appropriate assessment or the EIA is just done in 3 months, just
No.
paper.
I haven't seen that case because I've worked on it and I didn't manage to such that in 3 months. Duration was about 2 years maybe.
And I don't remember. I have mentioned there. I don't remember if I mentioned. It's right in there. In Greece, we have a big discussion about listed protected species, which means that okay, some species are included in the catalog in the list, and the other side is the protected species, because we don't have protected species. In fact,
Okay.
we have only protected listed species. If you want to go to be protected, you have to implement what you say.
Yes.
And now,
supplementary.
now the only light in the end of the tunnel is that there is a reaction with a lot of local people against the construction of especially wind farms in crucial places like in Natura or in touristic places. Only with the press of the society can be something good solution in a good, let's say, direction.
So
they ignore it.
you have the situation in Greece.
We see the map. We see the map. It's open. We can go to Natura 2000 viewer and go to the RAA, the RAE, the Greek authority from the energy, let's say, silence. You can see the map. We can Google to see that.
Yeah.
And we can see with different colors which there are some categories, let's say, of the wind turbines. With the yellow is ready to get the license. With green is ready to construct, already constructed. All the phases. How the EIA has improved. It's obvious. There.
Absolutely. Greece is not easy. It's first not easy, but I would say that
I know what happens in other countries. I know, unfortunately, what happens in Greece as well. But this is the reality.
Yeah, sure.
And the worst thing, as we discussed with the stakeholders, is that EU knows the NGOs have made, let's say, a legal act against. We still wait the feedback from the EU. But yeah, since 5 years ago. So this is the situation.
It depends on how have been designed Natura 2000 in each country. And it have been an awful fight in France between NGOs and administration to not design some of them. But the fact is that the knowledge came after the Natura 2000 designation. And you could have few important places that are not in Natura 2000 network, but must be taken into consideration. And it does not minor the role of Natura 2000. administration. Yeah, this is trouble.
And another case is to see if you make it's connected with a fast track EIA. It's a typical process. There's no Baki. Baki, it's a joke. Baki is unknown word. There's no Baki in the Greek terminology. There's no at all. It's an idea that ecologists are, let's say, try to establish. It was difficult to have before. There's no. It's all fast track. It's all fast track. And the copy paste, as Maria said, it's a routine. I have seen a study describing pine, let's say, Mediterranean ecosystem, and connected for the road to be, let's say, approved for the habitat of the bears and the wolves. Describing Pinus halepensis in bear habitats. Nobody read the EIA. Yes. You understand?
Yeah,
This is the reality. Please, Radu.
Thank you. If I may have a question for the last two presenters, for Marlene and Tobias. I'm curious if you have also set up some sort of feedback mechanism to get, I don't know, any issues or questions from the engineers in the field, and if there's any chance to adapt the guidelines based on what they faced in the field. And it's the same way for the people who are doing using the standards for mapping. If they found something that is not already standardized, how you include this new feedback. Thank you.
It was a very short presentation, but it's obvious that this is going together with a big information within the organization, and working together with them. And if they have questions, that we are available to help them. So it's not only the Vademecum. So the Vademecum is also a publication from 2023. And I hear that it's used, but I can't evaluate how well it is used for the moment. It's not only focused on inside our organization, but also outside. So, and it's a first publication. It's not on paper, so it can be adapted in the future to new insights or things that are missing. Question that will reach us to make it better. So,
thank you. Yes, about taking care of feedback from those using the consultancies and other stakeholders using the Swedish standards for nature service. This is a standard under the Swedish Standards Institute, and there are rules. So the first revision, or the first edition of this standard was published in 2014. And then you need to, according to those rules, every 5 years, you need to decide if a new revision is needed. So and there were some kind of childhood issues with the first edition. So in 2018, such a decision was made to do a revision. And a second edition, which I listened to feedback from consultants and from us at the Transport Administration and other parties. A new edition came out in 2023. So then the cycle goes on, and in 5 years we'll decide if we need a new revision. And now we're currently getting questions from consultancies on this new revision and working to provide answers to those questions on the committee websites, for instance. Yes.
Thank you very much.
And if you don't have any other question, last chance. So it's time to say thank you very much. I try to give you 2-3 minutes extra if you understand it, just to manage a little bit the time. And I think it was a nice session. I would like very much to thank all of you for questions, for worrying, and the presenters. And I hope you all the best for the rest of the conference. Enjoy the poster session and much more later dinner of the conference. Thank you very much.